It's from the person you're observing's perspective. Okay? Left ankle, right ankle, left elbow, right elbow. So important because people are going to get it wrong. When you're analyzing someone, it's from their perspective. You can become them, and y'all can both see the same thing. But when you're analyzing someone's position, joints, injuries, bones, whatever, you have to remember you're analyzing it from their perspective, rights and lefts. Okay? All right? Okay. The second thing we are going to develop today is practicing concepts of general and pure rotation. So pure rotation, right, would be when all of the mass is rotating about an axis, about a fixed point, about a fulcrum. So yes, this part is going up and across, but it's canceled by this part going down and across, kind of the opposite linear direction. So they all cancel out. So the center of mass isn't going anywhere. Does that make sense? How this applies to human movement is, imagine this was like a propeller. You were looking on the top of a helicopter, and I'm missing two things, but if we just looked at one propeller, one slice. So in other words, there's like a toy helicopter that I've been playing with for a while, so I broke off 3 of the propellers, and now this one's moving by itself. Well, this isn't pure rotation anymore. There's some rotation, but there's also some translation of the center mass, because the center mass is now not here, it's over here. So now we could say things like, oh, it's going down and to your left. Well, now it's going up and to your left. Whoa, 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 whoa. Now it's going up and to your right. Now it's going down and to your right. You see how the linearity keeps changing? But the rotation doesn't. It was spinning the same way the whole time. It was spinning as you perceive it clockwise the whole time. The rotation didn't change. But the linearness did. Up, down, left, right, that changed. And that's why for our joint motions, that is exactly why we don't use terms like up and down and forward and back, because the linearity changes in general motion, but the rotation doesn't. Does that make sense? So in other words, if we say, I'm going to learn flexion as my lower arm goes forward, well, what's going to happen when eventually it goes back? I'm going to learn abduction as my lower arm goes away from my midline. Well, what's going to happen when it keeps spinning and then it comes back? Does that make sense? But what doesn't change is the spin. From your perspective, my elbow was rotating clockwise the entire time, regardless of if it was going forward or coming back, regardless of if it was going right or left. The spin was the same. So in general motion, we're going to have a lot of joint motions that have general motion, but we can extract the linearity from it and only hold on to the rotational component of it. Joint motions are going to be because of the spin, even though there's going to be some linearity to the general motion, because the spin won't change. Cool? All right. Let us go to planes of motion. So if I'm telling you that our joint motions are going to be from rotational perspectives, then we are always going to associate planes and axes. Remember, planes, not a view of something, a spin of something. 3 dimensions in which things can spin. We need names of these 3 dimensions, and we need names of the axes that these 3 dimensions can spin about. Again, what's kind of cool is there's a lot of different that's not that many, but we just have to settle on what we're going to call these in class. So some of you may have heard, or some textbooks may talk about a coronal plane. It's okay. There's different names for different things. I think I mentioned this last week. In England, they call it a biscuit, and we call it a cookie. But it's 2 different words for the same thing. In our class, we're going to use sagittal, frontal, and transverse as our 3 dimensions of spin, 3 dimensions of rotation. Now, ladies and gentlemen, boys and girls, fellow people who are just abnormally cold right now, we understand that life isn't about robot world, Like we have north, south, east, and west, but you're rarely going to travel perfectly north or south or east, west. Everything's going to be kind of a combination. Okay? No different in planes and axes. We are going to start out in robot work, where we're going to talk about the 3 planes. But in the real world, we're going to move in a combination of these planes, and that's okay. Just like you could figure out if someone's going northeast or northwest, you say, well, some of that movement is north, some of that movement is east. No problem. Well, when we have combinational spins, I'll give you an example. This I'm going to teach you as frontal. This I'm going to teach you as sagittal. But what happens if we do this? That's not a new plane. That's just some of it is spinning this way and some of it is spinning that way. And when you put those two together, it looks like this. Some of the spin is sagittal, some of the spin is frontal, and it's a combination. Okay? 3 dimensions of rotational spin. I like to look at it from an axial perspective first. Some of you may see it planar perspective first. In other words, you may see the spin and then associate the axis. That's fine. I just want right answers. So just know that some of you may have an easier time seeing the spin and then saying, what did it spin about? Or how was it able to spin? Some of you may see a spin and say, okay, let me establish how it's spinning or what it's spinning about. Then I know the plane it's spinning in. One of the best things about planes and axes, guys, is they don't disassociate. It's a married concept, and the divorce rate is 0. Whatever plane is rotating in, the axis must be so. It cannot change. And I'll give you a simple example of how that works. If I have an axis and I have a plane of spin, and I'm spinning it, right? And we're going to call this the sagittal plane eventually. But if I change the axis, I have to change the spin. They have to change together. In other words, if Simone Biles was rotating about the bar, and she was rotating like this, it's impossible for her to rotate around the bar like this, and it's impossible for her to rotate around the bar like this. There's only one way she could go around the bar. Does that make sense? Whether the bar is here, whether the bar is here, or there are special gymnasts that make money performing where the bar is here. Okay. All right, guys, so what are our planes of motion? I tried to break it down because sometimes you'll see these pictures and all 3 planes are all combined. To me, it's just too much. So I like to separate them. Remember, our instinct is to look at these planes linearly, like a view. And I tried to explain why for us, rotations isn't about how you see something, it's about how something is spinning. Also note, how many of you have ever heard, well, a plane separates the body into halves, right? That for us, think about how little sense that makes, because we're going to be talking about planes of our elbows and our wrists and things that aren't in the middle of our body, right? Like we're going to be talking about how our joints can rotate in planes and axes, and it has nothing to do about the midline. The application of it separates us into halves is to find the center of mass of our body, which transects those 3 planes. And if our whole body was spinning, it would be about that fixed point. Like if I was doing a front flip or a back flip, which I totally can, but I don't want to show off right now, all right? It's too cold. So don't get caught up with these cliche separates the body from right. I mean, that has nothing to do with my right elbow, my left elbow, my right knee, my left knee. The fact is, these planes are in every single one of our joints. These axes are in every single one of our joints. There's not just one axis that goes here. There's an axis here, and here, and there, and here, and there, and there, and there. So although these traditional views can help to introduce you to spins and axes, don't think this is like the end all be all. These planes and axes are found in every single joint of our body. Okay? Does that make sense? All right. The first one. We have an anterior posterior axis that we call the AP axis. And I would like for you to think of the AP axis. I always try to bring things into layman's terms, into simplistic terms. We define the front of class and the back of class. This is the front of class. This is where the projector's at. This is the back of class. Top, the bottom, and the sides. I know this class is kind of shaped differently, but if this is the front and the back, those got to be the sides. In anatomical position, I know y'all been introduced to that, but anatomical position, true anatomical position, the intent is for linear and rotational to all kind of start in the same place. What does that mean? When I'm in true anatomical position, this is my front, just like this is the front of class. This is the front of me, it's the front of class. This is the back of me, it's the back of class. This is the sides of me, it's the sides of class, and this is the top and the bottom of me. That's where you get terms like dorsal and ventral and superior and inferior. That only means something because you establish what's front, what's back, what's side, what's up, what's down. Okay? So an axis, a fixed point that runs from the front to the back of class or through you is an AP axis, an anterior posterior axis. Now, we don't just have one anterior posterior axis. We have several. Here's the anterior posterior axis of my shoulder. Here's the anterior posterior axis of my hip. Let me practice. Right shoulder, right hip, right knee, right ankle, left elbow, left wrist. Okay? If Simone Biles, if this was an anterior posterior axis running front to back or back to front, doesn't matter. Because I-10 is one road, but you could go east or west. The AP axis is one axis, but you can go front to back or back to front, doesn't matter. Meaning from here to there or back to here, it doesn't matter, it's the same pole. So if Simone Biles was going to rotate, y'all know who Simone Biles is? Just probably the greatest athlete of all time. If she was going to rotate about an anterior posterior axis, there's only one way she can spin. She can only spin around the pole like this. That's it. She can't rotate. She could sway, but she can't spin like this, and she cannot spin like this. She must spin in a plane that is perpendicular to that axis. And we have to name it something. So we are going to call that plane the frontal plane. Frontal plane rotations occur about an anterior posterior axis every time. We're going to get into perspectives after. Let's just define the planes and axes based off of how they're legitimately named. What if the pole, let me make sure I can get in. So what we established is front to back pole. Simone has to spin perpendicular to it. We call that the front plane. What if the pole, the high bar, is like this? Well, that's no longer front to back. That's now side to side. We call that a bilateral axis. That makes sense. Bi, side to side. A side to side axis, a bilateral axis. And the only way Simone can spin like this is perpendicular to it, right? She has to rotate around the bar in this plane of spin. And think about it, whether she's spinning like this or like this, clockwise or counterclockwise, it's still the same plane. It's still the same spin. Whether your car is going forward or in reverse, the tire is still spinning in the same plane. Going east or west on I-10, you're still traveling on I-10. That's what I'm trying to get you to see in a linear world. We call this plane the sagittal plane. Sagittal plane rotations occur about a bilateral axis. So, examples. What we call it doesn't matter right now. If you see my shoulder having a component of rotation, yes, there's general motion, but joint motions are going to be from the rotational component. How is my shoulder rotating? Some of you are going to be able to see the spin. That's actually how I see it. I could see, like, what if my shoulder was able to keep spinning, and then I just see like this blur of spin like a tire. And I say, oh, that's frontal plane, and it's because of an anterior-posterior axis. Everybody see that? And it doesn't matter that I'm spinning in your perspective clockwise or counterclockwise. It's still in the same dimension of spin. What about this? Well, a bilateral axis. Objects rotate in a sagittal plane about a bilateral axis. Make sense? What about this? Bilateral axis, sagittal plane. What about this? Bilateral axis, sagittal plane. What about this? Anterior-posterior axis, frontal plane. What about this? Anterior-posterior axis, frontal plane. Sagittal. Yes? Frontal. Sagittal. Sense? The reason we started with sagittal and frontal, they're kind of the most related. When you have something like your neck that's going to be kind of bending, like swaying like a slinky, there's a lot of general motion there. My head's going forward, my head's coming up, my head's going down, my head's coming up. But when we talk about this last plane, there's kind of like when we were in elementary school, which one doesn't belong? Apple, banana, strawberry, sledgehammer? Yes, I know this one. What doesn't belong? What looks different? The frontal of the neck, the sagittal of the neck, or this plane of the neck? Right. Look how there's hardly any, if any, linear work being done, right? There's no motion other than pure spin. And that's what we're going to call the transverse plane about a polar axis. A pole or axis, top to bottom, bottom to top. Things have to rotate in a transverse plane about a polar axis. And I always thought this made sense, like it's elegant. I like when things connect. I know you guys have heard of flexion extension. I know you guys have heard of abduction and adduction, but you ever thought about why the sledgehammer is there? Flexion extension, well, that's a form of rotation. Abduction, adduction, that's a form of rotation. But then all of a sudden we get into internal and external, and they actually have rotation in the name. Internal and external rotation. We didn't say flexion rotation. And the reason is because joint motions that have rotation in them are more pure rotation. It's not as general. It's more like this and less like this. Example. Let's pretend I had 75-pound dumbbells. We're going to do a lot of pretending. Could I move those things in the frontal plane? Could I move those things in the sagittal plane? But I could move those things all day to transverse. Woo, look at me. Illusionists will do this all the time, where they'll pull like a plane, or they'll pull something heavy, and it's rolling. And I'm like, that's amazing. Lift it up. That's what I want to see. Do that with your teeth. You see the difference? There's some linearity with this general motion. There's some linearity with this general motion. There's no linearity here. So it'll have a rotationary name to it. Okay? So 3 planes of motion: sagittal, frontal, transverse, about 3 axes. My friends in kinesiology, it is so important that We give unto Caesar what is Caesar's, as Dr. George used to say. If I ask you for an axis on the test, I'm talking about the point about which the rotation occurs. If I ask you about a plane on a question, I'm asking you literally the dimension it's spinning in. Objects rotate in planes, just like you swim in a pool, but objects rotate about an axis. Yes, sir? Sorry. Absolutely. Objects rotate in planes. It's a dimension of spin, and objects rotate about an axis. It's in your materials as well. Okay. All right, let's practice. What plane is the spin in? Frontal. What axis is it about? Anterior, posterior. Okay. What if I did this? Same spin of the clock. Sagittal, about. Transverse, about. Good. Okay. Let's try a different application. Sagittal, about. Bilateral. Okay. Does it matter if I spin it forward or spin it back? No, it doesn't. You know what that will matter? Whether we call something flexion or extension. That's going to matter if we call it ab or ad, or right transverse or left transverse. But right now, we're just trying to establish the roads. We're trying to establish am I on I-10 or am I on I-20? Am I on I-10 or am I on I-49? We're just trying to establish the roads, and then eventually we'll add what do we call the motion in the road, okay? All right, what about this? Frontal, about, anterior, posterior. Okay, what about this? Let's see if I can do it. I haven't done it in a long time. Transverse, about a polar. Good. Okay. Any questions so far? Guys, if you are awake, you can practice this stuff. If the door opens and closes, what plane would that be in? Transverse. This door would be an example of general motion because the mass of the door is going out, coming in. But a revolving door, y'all know what that is? Like if you're at a fancy schmancy hotel and you have a revolving door, that's more pure rotation. Door's not going. Okay. So that would be transverse. A ceiling fan would be transverse, but like a desk fan, well, depending on where it is, if it was blowing here, it'd be frontal. And if it was blowing from the side, it'd be sagittal. What if the ball was rolling? Okay, get back to it. General motion, right? So we separate linear from rotational. Linear was going to the back of class. But rotational, it was spinning in the sagittal plane. And it would still be rotating in the sagittal plane if the ball rotated back to me. Like it didn't matter. Like the spin, whether it's this way or that way, is in the same plane. Once again, that's why flexion and extension will be in the same plane. Clockwise and counterclockwise is in the same plane. Two different spins in the same plane. Okay? All right. Now we will get into perspective. Everything is nice and clean right now. Front, back, side to side. I see back, I see front. Everybody's seeing the same thing. Perspective can change. And I need you guys to understand that that's okay and it's normal. What we have to remember is whose perspective is of importance. What do I mean by that? If you ever had an argument with a family member, a friend, a loved one, sometimes like you got to talk about it, say, oh, now I see where you're coming from, right? I see your perspective. Very similar to planes and axes. I'll give you an example. Okay? You say, this is sagittal plane rotation on my shoulder. Okay? I see a bilateral axis, and I see spin perpendicular to it. But what if I turn my head this way? I'll make it easier. Walk forward. Got that, man. Walk forward. Oh, snap. Do I go here? Or do I go with what I see is forward? See what I'm getting at? Okay. So perspective can change. Trust me, I'm going to make this simple. Every joint has a perspective, just like my eyes. You know this from basic anatomy. This is the front of my elbow. This is the front of my wrist. This is the front of my shoulder. This is the back of my knee. Here's the key. We don't live life like this. We live life in different positions. And the front of my elbow can face the front of class, but the front of my elbow can also face the side of class. The front of my elbow can face the top of the room. The front of my elbow can face the bottom of the room. In other words, our joints don't always have to match up with the room's perspective of front, back, left, right, up, down. Our joints don't always have to match up with what we are comfortable with, frontal, sagittal, and transverse. Every single one of our joints has their own planes and axes. Every single one of our joints has their own sagittal, frontal, and transverse that move with them. Let me give you an example of what I mean. Elbow, move in the sagittal plane. Elbow's like, no problem. We're going to call this flexion and extension. I'm going to define it. It's going to be a lot easier than what you've learned in the past. But if I rotate my shoulder, this is still the front of my elbow, right? Front of my elbow. This isn't the side of my elbow. This isn't the lateral side. It's still the front of my elbow. So now my elbow is rotating in the room's frontal plane. But for my elbow, it's as if his eyes move with him, and it's like, dude, I'm still doing the same thing I was doing when I was down here. I'm still moving the exact same way. That is what we call a local reference. In physiology, y'all have heard this before. Absolute and relative VO2 or relative to body weight, right? You've heard that before. That's all this is, just in physics and biomechanics. A global reference is like what the room sees. Because I'm not changing the fact that this is the front and the back of the room. It's not going to move. It's not going to go anywhere. I'm not going to change the fact that this is the top and the bottom of the room. It's not going to go anywhere. I'm not going to change that these are the sides of the room. But you know what can change? The front and the back of my elbow can change relative to the room. And when we're talking about our joint motions, our right, our left, the planes and axes of our different joint motions are from their perspective. It's relative to them, not the room. Yes, ma'am.
So if you were asking the question about like this you answered like if we were to put it back.
First of all, we're going to do a lot of practice, but it depends on the question. So, in other words, if I say, how is my elbow rotating in the room's, from the room's perspective, right? This would be sagittal, this would be frontal, and this would be transverse. But I've established that I just want a global reference, room's perspective, sagittal, frontal, transverse. But from my elbow's perspective, Front of my elbow, back of my elbow. Outside of my elbow, we call that lateral. Inside of my elbow, we call that medial, right? So here's my bilateral axis of my elbow. From my elbow's perspective, sagittal, sagittal, sagittal. Because this will always be the lateral part. This will always be the medial. This will always be a bilateral axis to my elbow. The confusion is from some students is they're like, I got it, sagittal, flexion, extension, I got it. But as soon as I make the elbow move in the root's frontal, they're telling me this is ab and adduction. And I'm trying to show them that no. Because when you did this, the front, the back, the side to side moved with you. The elbow has no clue what's happening out there. The elbow just knows I can only move in my sagittal plane. If your elbow moves in its frontal plane, it's a bad day, right? So that's what we're trying to avoid by kind of using this verbiage, is to eventually eliminate illusions that are going to be coming down the pipeline, such as this is not ab and adduction. This is still just as much flexion and extension, just as much as this is flexion extension, just as much as this is flexion extension. Because flexion and extension is about the joint's perspective. And that perspective is local to that joint. Question. Thank you for asking. And we're going to develop these. I promise we're going to practice. We're going to develop. Okay? So we have global reference, which the easiest way to look at this is it's from the room's perspective. It doesn't change. North is north, south is south in a linear analogy. Right? You're on the compass, it's always pointing north no matter what position you're in. If we scattered around the room in all different, some of you laying down, some of you standing, facing everywhere, and I said on the count of 3, point to the front of class, we're all going to point in the same direction. That's a fixed global reference. Guys, those are important. Those are important. Global references are important for like GPS, right? But for our body, especially these illusions, we have to understand that planes and axes aren't fixed. They can move with the joint. Think of it as a mobile home or a trailer that can be moved. It's not found, it's not, fixed onto the ground. You could literally make a movable home. The door could open east, or you could move to a new part of town and the door could open west. Our joints are locally referenced. That means the planes and axes that they have move with them. I promise you we will practice this a lot, okay? But an important concept. All right, guys, this is a great slide because I made it. No. Here is to me, this is a great slide because it allows us to practice the concepts of planes and axes. However, when I first made this was when we had printout copies of the source material. And if you're looking at something on your desk, I can't match it on the board because we have to see it. So I actually have to rotate it for everybody to see, okay? So what I tried to do was make it in a way that us seeing it on the board is actually what's happening in the room. Let me see if I can make some sense of that. If we're looking at it on the screen, from the room's perspective, my ink pen is side to side, bilateral axis, sagittal plane spin of my CD. My pen is front to back, back to front. Spin would be frontal plane. And then from the bottom, top to bottom. So the reason I'm telling you this is that if you're looking at your device on the table, it may not make sense. So you have to move your device to match up with the screen. Does that make sense? Make sense? So all you have to do is just study with it matched up on the screen, because I wanted it to be as if y'all were watching it on the video. Cool? Okay. I talked about this last week, how planes can be views, but not for rotation. If I'm going to watch a movie, I want to watch it so that I can see 2 dimensions, left, right, up, down. If I want to see a 3D movie, I put on special glasses to get it depth. But a plane, like if you were going to do an X-ray or an MRI, it would be like, that's what in medicine, when I was an athletic trainer, Dr. Comstock would say, give me an AP lateral view. And what was cool is the view was from the axis, because that's how you would want to see something. If I want to watch Simone Biles do the bar and she's spinning like this, wouldn't I want to watch it from an anterior or a posterior view? I don't want to watch it from a side view if she's spinning in the frontal. I wouldn't get a good view of that. Think of it like this. The best seats for an NFL game are on the 50-yard line, right? Because then you can see all the action. It's harder to see it from the same line of view, okay? So an AP view of an X-ray or an MRI means you're looking from the front. But you're going to see the stuff like on the screen, okay? So I have that in there just in case some of you are confused about, well, we use planes in our clinic and X-ray MRIs. Guys, planes can be used linearly, but the way we're going to use it for joint motions is rotationally, and so they have to have an axis. Axis is spin. You're never going to do an MRI with a plane and an axis, in other words. All right, this is the part of perspective, guys. This is what I just lectured about, okay? Absolute global reference, relative local reference. So, in other words, Simone Biles, keeping with the same analogy, Simone Biles is doing the high bar for us in class, and she is rotating about the bar from the room's frontal plane, and from how you guys see it, your frontal plane. But Simone is spinning her sagittal plane. Like, to her, this is like front and back spin. Better analogy. How is the ball rolling? Well, to me, it's going forward, but to you, it's going to the side. Both are acceptable as long as we communicate who's seeing what. Both are acceptable as long as we're communicating who's seeing what. From my perspective, that's sagittal spin of the basketball. And from your perspective, that's frontal spin of the basketball. Applying it to the human body, right? What my knee may see is different than what my shoulder may see. And that's okay. Because if I'm talking about my knee, it's from my knee's perspective. Hey, knee, what's happening to you? My knee's like, I'm flexing and I'm extending. My knee's like, I'm still flexing and extending. My knee's like, dude, I'm still flexing and extending. It doesn't matter how it may look from a room's perspective. If I'm asking about my knee, it's almost like I'm interviewing my knee. Like you'd be interviewing a player. Okay? One of the biggest problems, and when I say this, I'm trying to help you. Our instincts are to want to bring everything to a room's perspective. Because it's comforting to us. Because we know from childhood what up and down is and what left and right is. But human motion doesn't care about your feelings. It doesn't care about what you're comfortable with. And that's why so many people get them wrong or don't see things that are moving or think they see things that are happening because we've always kind of brought things in this linear room perspective. But it's from the joint's perspective. And we analyze motion joint by joint. That's one of your commandments. Guys, there's going to be times when you're a coach or a therapist where you're going to have some complex things happening. And one of the things I'm going to teach you to do is, no problem. Let's start with the ankle. What did the left ankle do? What did the right ankle do? What did the left subtalar do? What did the right subtalar do? What did the right knee do? What did the left knee do? Analyze motion joint by joint because those joints can only do so many things in their own planes and axes. There's a better analogy. Although that might have been a good analogy. This might be better. Think of it as you have NFL playoffs happening. My wedding ring is on my right hand because I'm a left-handed player, and I have a theory that wedding rings go on the left hand, not because it's close to your heart, it's because the majority of people are right-handed. So they don't struggle like I do having to move it over when I want to throw or pitch or hit. So that's why that's it. Where was I, Ron? Start from the beginning. The earth cooled, dinosaurs came. NFL, you have 11 players on offense running one play as a unit. And that play may be successful, may score a touchdown. In other words, it's several different pieces all working together to do one task. And you, basketball, soccer, whatever your world is. So think about it. It's very similar. I'm trying to make a free throw. It's one task, but there's a lot of different players. It's a lot of different players. My right knee is a player. My left knee is a player. My right hip is a player. My left hip is a player. My trunk is a player. My right shoulder, my left shoulder. All these different players are running a play that sometimes we take for granted as a skill or a movement. So what I'm going to teach you is we analyze all these different things joint by joint. We don't follow the ball. In fact, I'm a ball follower because I don't know the intricacies. I was a defensive back and a wide receiver at a single A school. You would laugh if you knew what our routes were named after letters. That's how simple our offense was, all right? But you know anyone who really knows football? They're not watching the ball. They're watching the lineman, right? They're watching other things. That's what I need to teach you. With an education, a real education in human movement, we don't want, if we're analyzing someone's motion, we don't want to get distracted by the ball. We don't want to get distracted by the hands. We want to analyze all the different things that are happening so that the football can be thrown to the wide receiver. Does that make sense? And that's why so many people get tripped up, because they're just looking at the so what. They get distracted. Okay? So perspective, global and local. Next class, if you want to read ahead, I know y'all know what anatomical position is. We're going to reestablish that, but I'm going to emphasize the importance of fetal position, why it's important, and why that unlocks the roads to flexion and extension. We're not going to learn motions with angles and things, because every time I decrease an angle on one side, I increase an angle on the other side. Super confusing. So I'm going to teach it to you in function. Flexions are sagittal plane motions that get you into fetal position. And extensions are sagittal plane motions that get you further away from the fetal position. That's how I'm going to teach you. It's going to make sense. All right, guys, y'all be warm.